Good afternoon, ladies and gentlemen. Welcome to today's webinar on SpectroDive 8, our latest release of SpectroDive, our proprietary software for the analysis of targeted proteomics data, meaning of multiple reaction monitoring or parallel reaction monitoring data. I'm your host, Florian Marti, Product Support Manager of Biognosis, and today's agenda is following. First, we're going to look shortly into the new Biognosis targeted proteomics portfolio that we recently relaunched. Then I'll show you a little introduction about SpectroDive 8. We look at some new features of SpectroDive 8, and in the end we will host a question and answering session. And for this session today, Oliver Bernhardt and Tejas Gandhi, senior scientists of Biognosis, will join me. 2 weeks ago, Biognosis has relaunched its targeted proteomics portfolio for the analysis of plasma proteins, and basically what we have done is we have made the two multiplexed assay panels, PlasmaDive and Plasma Deep Dive, modularized, and in a way now that the researchers and the users can order all individual parts of the kits separately. So the user has now the option to order the sample preparation kit Pro directly from our shop. He or she can also order the PlasmaDive and PlasmaDive reference peptides, and also the software SpectroDive is available as it was before. The integrated PlasmaDive and Plasma Deep Dive assay panels, they also remain in our shop and can be bought as an integrated workflow, much as it was before. About 2 weeks ago, Professor Manuel Meyer has already showcased how PlasmaDive and Plasma Deep Dive can be used in plasma proteomics in a very nicely webinar entitled Plasma Proteomics in Cardiovascular Epidemiology. You can review that webinar on our Biognosis Science Hub located at www.biognosis.com/sciencehub. The focus of today's webinar will be on the back-end part of our targeted proteomics portfolio, our proprietary software SpectroDive. About a month ago, we have released SpectroDive 8, our latest release of SpectroDive. SpectroDive is built on the IRT concept and uses the IRT peptides for targeted and scheduled MRM and PRM measurements. Key features of the new software are: it has the best peak picking algorithm, which is based on an extended version of the mProfit algorithm, which was initially developed by Lucas Reiter and colleagues. The peak picking algorithm is very similar to the algorithm we use in Spectronaut. The developers have further worked on the software to make it scalable to hundreds to thousands of runs without the need for extensive computational resources. For the parallel reaction monitoring or PRM workflow, we have added automated mass calibration. The biggest and newest feature of the new software is by far the very fast, easy to set up, and high quality panel generation from shotgun results on the basis of spectral libraries. And this I will showcase you later in great detail. With this, we've also optimized the compatibility between Spectronaut and SpectroDive to basically go from discovery projects using hyperreaction monitoring mass spectrometry in Spectronaut to targeted follow-up studies using SpectroDive and targeted proteomics, MRM and PRM. Comparable to Spectronaut, SpectroDive also has an integrated quality control perspective, which uses the IRT kits as it is done, for example, also in our dedicated QC software Quick. Further, SpectroDive 8 also does statistical testing for differentially abundant candidate. As most of our software, again, it's very similar to what Spectronaut does. It is set up in a similar way, and it's very straightforward. I will now show you some screenshots of SpectroDive 8, walk you through the new perspectives that we have added, and explain you what the new features are in each and every perspective. First and foremost, as I mentioned before, we have added a so-called library perspective, which is very much the same as the prepare perspective in SpectroNow. This enables the user now in SpectroDive to generate spectral libraries directly from shotgun data using the search engines MaxQuant, Protein Pilot, and Proteome Discoverer. These libraries can then further be used to generate targeted assay panels, which are used to monitor the proteins of interest. As I already mentioned, the library perspective is the same as in SpectroNow, so we also have Biognosys spectral libraries that can be downloaded from the internet, which are either libraries that Biognosys created or publicly available resource spectral libraries, such as the Pan-Human library created by Rudy Ebersol's lab. The new library perspective also enables an easy transfer from DIA results, from DIA discovery results, directly into follow-up studies using PRM or MRM. The next perspective, the prepare perspective, which was already implemented into SpectroDive 8, we have added on top of the import panel, we have added the function to generate new panels down here from spectral libraries. On top of that, people can also import existing panels that have been created either in SpectroDive or in other softwares. After panel generation, the panel is stored here on the left, which I will show you again later how it's done, and the software can then be used also to set up the method for either MRM or PRM. For method support, we are currently supporting Thermo Fisher, SciEx, and Agilent instruments. As you can see down here, where you have drop-down menus where you can select which vendor you're using, which instrument of that particular vendor, and then export your method. For PRM measurements, we are also allowing the user to perform IRT refinement, which basically enables the user then to have very narrow windows and very accurate IRT calibrations for the peptides of interest. When generating a new panel from a spectral library, the software will prompt you to a new window where the researcher can select the spectral library from which a panel should be generated. As I said, panel generation can be done from resource spectral libraries or from spectral libraries generated either directly in SpectroDive or imported from SpectroNow. The logic behind the panel generation based on spectral libraries is that we use automated filter criteria that are set up in the process of the spectral library generation, but also enable the user to manually select additional features of the spectral library to build a panel that works straightforwardly in SpectroDive. After loading the spectral library, the software will show you here a list of all the proteins on the left. When clicking on one protein and expanding that protein's view, we see the different peptides that are in the spectral library. On the right side of the plot, we have the protein displayed with its amino acid sequence and color-coded the peptides that are in the spectral library. In dark green, we have, as you can see here, the selected peptides. In light green, we have the proteotypic peptide, and in red, we have the peptides that are not proteotypic. If you look at the peptide list under a protein, the peptides are already ordered by rank base, and normally one selects the top ranked peptide whenever the peptide is proteotypic. In this case, I've selected here just the second ranked peptide because the first ranked peptide is not proteotypic, and I wanted to have proteotypic peptides only in my panel. As most of you are aware, you can also already select proteotypicity in the spectral library generation part. In that case, you would only see proteotypic peptides here. After selecting a set of protein and peptides, the next screen is then showing you all the different proteins with the peptide selected. And here on the right side, based on the automated feature settings, the fragments that are chosen for monitoring. As you can see here, for all the peptides, we are selecting the top 3 fragments with different settings here. Down here, the theoretical spectrum is showed based on the data in the spectral library, which again enables the user to select better fragments whenever he or she thinks that the software did not pick the best fragment. Also, the settings up here can be manually changed, and by hitting the Apply Settings button, the settings will be taken over, and the selection of fragments for every given peptide changes. In the next step, the user can then select whether the targeted proteomics workflow that is measured is actually label-free, labeled. So, for example, silent label, or if it is a spike-in, where you spike in heavy labeled peptides into an unlabeled background, or the inverted spike-in workflow. For all the different workflows here on the right, we have a drop-down menu where almost all known labels are present and can be selected. The software is then automatically creating the labeled part of the panel based on the unlabeled data from the spectral library. Last, when doing the panel generation, the user can then select whether the panel will be used for multiple reaction monitoring, MRM, or the panel will be used for parallel reaction monitoring, where, as you all know, no fragment ions are targeted. Down here are then the key features of the panel, as it will be displayed also in the software. After panel generation, as I mentioned before, the panels will be stored here on the left side in the prepare perspective under all different panels. And to set up the method, one goes then step by step through the software, from first choosing which panel wants to be analyzed, then selecting on the right side here the corresponding calibration run for the instrument on which the analysis should be performed, and last, setting up the export method by choosing the correct instrument, the correct method. So, for example, on the Q-Executive HF, we can do PRM analysis. So we would select down here the corresponding instrument, and also performing first an IRT refinement run to very narrowly determine the IRT values of all the peptides in the panel. After the method setup, the method can be exported down here using the export method button, and then be imported in the instrument file to perform the targeted analysis. Once the data is acquired, the next step is the data analysis that is performed under the review perspective by selecting the raw files from the corresponding folder. As always, the experiment can be renamed to better fit the experimental purposes. Then we see down here the experiment with all the runs. The next step, it's already done here, is assigning the corresponding panel to each and every run. that so that the data can be extracted from the raw files. Further down here, the user can then select different settings and optimize the settings to the needs of the experiment. And when done selecting the different settings, hit the start button, and the analysis starts with the raw files. After the analysis is done, the individual runs are displayed here under the experiment, where we also display the different panels. So both in this case, the IRT and the PlasmaDive panel can be reviewed individually. Much as in SpectroNow, we have under the run level, we have the illusion group level, and as you can see here now, where we have a spike in workflow, you can actually see both precursors of a given peptide under the same illusion group. So we have first the unlabeled and then the labeled precursor. On the right side here, the software determines the target to reference ratio, so the light to heavy ratio. And for PlasmaDive and PlasmaDeepDive, when using the integrated assay panel, the software also calculates you the absolute quantity of your protein of interest in solution, as you can see here. Again, on the left side here, under the filters, you have all kind of different filter options where you can look into the data and review your data more carefully. As always in our softwares, the software is programmed in a way that the automated settings are fulfilling a great job, but we leave the option to the user to refine all the settings and refine the peak pickings based on the needs. In the next perspective, the post-analysis perspective, we have added some information to display the data. So first of all, we have the analysis overview, where we show the identifications in sparse, so how many proteins out of the panel have been identified at least once, and down here in full profiles, how many of the proteins and the precursors have been identified in each and every run. Data completeness, the same here. In this case, just 2 technical replicates of plasma to show how the data looks. And also the library recovery, similar to the value in sparse, so how much of the panel could be recovered. Then the median CVs over the entire experiment. So I just said 2 replicates each, so it's 2 biological replicates actually, both measured in technical replicates as well, to show the median CVs for technical replicates, but also to show the median CVs for biological replicates. As in SpectroNow, we have a lot of the plots here under the data completeness in a more graphical way. Then we have added the CVs below X plot, as it is depicted here. As you can see here, the very left is for the condition 1. In red, the number of precursors identified. In dark gray, the number of precursors identified with a CV below 20%. Our benchmarking set to assess technical variability in technical replicates. And then here on the far right, the light gray plot shows the number of precursors identified with a CV below 10% for condition 1. Same here for condition 2, so identified below CV of 20%, and identified below a CV of 10%. We're also giving out the scoring histograms under this tab here. So the scoring histograms for the label-free workflow, the scoring histogram for the spike-in for the heavy labeled peptides. Then under differential abundance, we have a candidates table. We have the p-value histograms, the all comparisons histograms, heat maps, and volcano plots. The candidates tab, as depicted here, shows you the values of the differential abundance testing. SpectroDive is doing like SpectroNout, a pairwise t-test of all features among all runs. You then see here all the information of the statistical test, such as the absolute average log2 ratios and the Q value, which is the P value corrected for multiple testing. On the right side, we have the protein profile plots, and under that the profile plots for the individual peptides measured for or the individual precursors measured for a given peptide or protein. In the next step, we have the report perspective, where the user can report and export all the necessary data for the downstream analysis. We provide with the software some factory settings reports, also some reports on our integrated assay panels, Plasma Deep Dive and Plasma Dive. But as always, the user can generate his or her own reporting schemas and save these schemas here for later use. Under the columns, there are all the fields that can be exported. If the user mouse overs one of the terms, a little tooltip will pop up and explain what the individual terms means. Down here we have a search function where the user can search different terms that should be incorporated into the report. On the right side here, then in this window, we have a report preview where we see all the information that is selected under the columns. And this is then how the report will look after exporting the report with the export report function on the lower left of the software. With this introduction, I hope I could show you some of the very cool new features that we have implemented into SpectroDive 8. As a summary, SpectroDive 8 is very easy to set up scheduled MRM or PRM measurements using the IRT concept based on an automated detection of the IRT peptides. It has by far the best peak picking algorithm based on an extended version of the mProfit algorithm, the same algorithm that's also implemented in SpectroNout. It has a very fast, easy to use, high quality and efficient spectral library and panel generation module that uses shotgun results from MaxQuant, Proteome Discover, and Protein Pilot to generate spectral libraries, which are subsequently used for the panel generation for the analysis of the targeted measurements. Then SpectroDive 8 is doing automated statistical testing for differential abundance of proteins in different conditions. And if SpectroDive 8 is used in combination with Plasma Dive and Plasma Deep Dive, an integrated workflow is delivered that gives you absolute quantities of plasma proteins in sample. With this, we're now coming to the end of today's webinar, and we are now happy to take any questions on Plasma Dive or Plasma Deep Dive, SpectroDive, or any other Biognosys product. Okay. We'll have support. Okay, the first question we have is, which Excalibur software versions are supported for panel export?
So right now we'll have a new update of SpectroDive in the next couple of days, and then it's up to Excalibur 4.
The next question is it necessary to spike in the HRM kit for spectral library generation?
It's not necessary for spectral library generation to contain neither the IRT kit nor the HRM kit, but it is recommended to have the IRT kit in order to perform better IRT calibration.
I can add to this a little comment about the spectral library generation and the work of the IRT peptides in general in SpectroDive and SpectroNaut. In especially SpectroNaut, all the IRT peptides are always used in a so-called three-pass analysis, where the first IRT calibration is done based on the IRT peptides. And when the IRT peptides are not in the sample, then the software has only the fallback option to go to the extensive IRT concept. And for some samples, their extensive IRT calibration set is actually not optimized, and therefore leads then to results that are not desired. Therefore, we always highly recommend to use the IRT peptides or the HRM peptides for the generation of spectral libraries. The next question is about the necessity of using IRT peptides in SpectroDive.
Yeah, it will still work. You will just, some of the features will not work in terms of exporting using for the transition list afterwards, because if you want to use that run to calibrate a new schedule method, you will not have the calibration there. So it's suboptimal, but the analysis will work without the IRT peptides.
The IRT peptides are also further required for the QC analysis. So if you don't have IRT peptides in your sample, as Tejas mentioned, the analysis will run through, but part will not work, such as the QC. The next question is, what is the best way to export results from SpectroNaut to create spectral libraries for SpectroDive?
So currently, this link is missing, but it's something we're looking into, so it'll be coming with a future update, perhaps. What? But you can obviously just get your candidates from SpectroNaut and then make a panel using the same library with the new panel generation workflow, and just select those peptides, your candidates, for making a final PRM/MRM panel.
Adding on that, what I did not show in this tutorial is the option to actually select or to input given peptides into the panel generation module. So the easiest way for this would be that you're basically copy-pasting the peptide sequence from the SpectroNaut results report into the panel generation module when loading the same spectral library that you have used to generate the spectral library for the DI analysis. If you're interested in getting a more in-depth tutorial about SpectroDive, feel free to contact us at support@biognosis.com, and we can schedule a one-on-one meeting and discuss more about the software. Next question is it possible to use shotgun data from Orbitrap XL in order to prepare targeted methods for an Agilent triple quadrupole? In theory, yes, this should work, and we know from different customers that are actually having similar workflows where they generate shotgun data for discovery projects and all kind of instruments, and then use the output to generate the transition lists in SpectroDive for Agilent triple quadrupoles or any other vendors the instruments that enable the user to perform MRM or PRM measurements. The next question is about the statistical analysis that SpectroDive is doing. Yeah. SpectroDive as a Spectronaut is doing a pairwise t-test to test for differential abundance.
Yeah.
Are there any other questions about SpectroDive or diagnosis-related products? If not, I'd like to mention once more, for all technical questions considering diagnosis, workflows, and products, our first resource, go to the Diagnosis Science Hub, located at diagnosis.com/Science Hub, where you find all our publications, white papers, application notes, also all recordings of past webinars, and it's a great resource of knowledge about proteomics in general, and more specifically about targeted proteomics and also discovery proteomics using hyperreaction monitoring. Additionally, as I said, if you have any technical questions, you can send us an email at support@diagnosis.com. As always in our webinar, shortly after the webinar, we will convert the recording and send you the recording in addition to all non-answered questions. With this, thank you for your attention and have a good day.